In today's video, first of all, I would like to wish best of luck for the CSIT second semester students who are going to attend TU exam soon. And we are in this video we are talking about mathematics 2 and some of the questions related to vector space. Let's talk about very important question here. This define the coordinate of x related to the basis b. The b coordinate of x. Coordinates, while we see this coordinates word, we think that either it is 2 dimension or 3 dimension, but here it is of n dimension. Look here, definition. Suppose, or let us consider, basis b is equal to b1 comma dot 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 bn. These are the vectors for b, and x is in b. X is also one element of this b vector space b. The coordinate of x relative to the basis b. The b coordinate of x are the weights c1 comma dot 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 cn, such that x is equal to c1 into vector b1 plus dot 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 plus cn into vector bn. This c1 and c1 dot 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 cn are the scalars and b1 dot 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 bn are the vectors. If we make the linear combination of this and equals to x, we write, then these c1 dot 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 cn are known as the coordinates of x relative to the basis b. These are many elements, and we can write this in the form of column also. Look here, if c1 comma dot 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 cn are the b coordinate of x, then the vector in R space n, we denote this by x coordinate x relative to the basis b. c1 dot 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 cn is the coordinate vector of x relative to b, or we write b coordinate vector of x. We say b coordinate vector of x for this. If we see one of the example, we can define here only the mapping is this. X is transformed into this x b, where this basis will play a vital role. How? Let's see example. This is the related question. You can consider b1 is equal to 2 1, this b2 is equal to this, x is equal to this, and this is a basis. Find the coordinate vector x of x relative to base b. How we organize the answer? We make the linear combination here, because coordinate vectors, these elements, this is in 2 dimension, so there will be c1 and c2. The b coordinates c1 and c2 of x satisfy what satisfy? Linear combination c1 into vector b1 plus c2 into vector b2 is equal to x. Now c1, you can put the value of b1 2 1 plus c2 minus 1 1 is equal to 4 5. Now you can easily solve this simultaneous equation. Look here, 2c1 minus c2 is equal to 4 and c1 plus c2 is equal to 5. You can solve by any method, although let's see how we are organizing here. We write in matrix form. Look here, 2 minus 1 1 1 c1 c2 is equal to 4 5. We consider this as b, and this is our coordinate vector relative to basis b. So this is b, this is coordinate vector of x related to basis b is equal to x. Now what will be this? You can transform this here. This will be inverse. Look, b is equal to this, then our this coordinate vector relative to basis b is equal to b inverse into x. What is the inverse? You can easily find 1 by determinant of a into adjoint a. Now you can simplify this. You will get first element 3, second element 2. Hence the solution will be c1 is equal to 3 and c2 is equal to 2. And so x is the linear combination of these two scalars 3 and 2, 3 b1 plus 2 b2, implies that this x coordinate vector of x relative to the basis b is equal to c1 c2 is equal to 3 2. This is the complete solution of the question. So you should not think this symbol is very tough. It is very simple. This symbol gives the output c1 c2. If there is 3 by 3, then we can find this inverse by Any other method, row operation method?